molecules escape from the surface of the liquid and more energetic faster molecules escape. So there will be slower and less energetic molecules that are left behind. Temperature of liquid decreases because average kinetic energy of remaining molecules is lower. Temperature of liquid decreases because average kinetic energy of remaining molecules is lower. Changes in the weather that help the wet cloth to dry more quickly is as temperature increases, more wind and clouds stopping the sun. Specific heat capacity of sun may be different from the battery. Some of the energy supplied by the heater hits the heater, goes to lagging, goes to surrounding. Specific heat capacity is lower than the value. Some energy may be absorbed from the surroundings if they are at a higher temperature, so specific heat capacity is higher than the value. The temperature of the sun on the beach is much higher than the temperature of the sea because specific heat capacity of water is much higher than the specific heat capacity of the sun, so the same rate of energy supplied to the sun and sea. The pan is made from aluminum, but handle is made from plastic. Aluminum is a good conductor of heat, and plastic is a poor conductor, does not conduct heat. In terms of molecules meant by an increase in internal energy is increase in kinetic energy of molecules and potential energy of molecules. In terms of atomic lattice and electrons, how thermal energy is transferred through the aluminum. In terms of atoms, lattice, and electrons, how thermal energy is transferred through the aluminum. So atoms touching the hot plate lattice vibrate faster. Atoms pass on the energy and vibrations to neighboring atoms by collisions. Atoms pass on the energy to electrons and electrons heat distance. Atoms, electrons move through the lattice. Atoms touching the hot plate and lattice will vibrate faster, and atom pass on the energy to vibrating and neighboring atoms to other atoms by collisions. Atoms pass on the energy to electrons. Electrons hit distant atoms, so electrons move through lattice. Atoms touching the hot plate and vibrate faster. Pass on energy to neighboring atoms. Atoms pass on energies to electrons. Electrons hit distant atoms. Electrons move through the lattice. Electrons hit distant atoms. Electrons move through the lattice. Electrons hit distant atoms. Electrons move through lattice. In terms of molecules, the effect of this thermal energy on the water, when eventually the water reaches boiling point, thermal energy from the hot plate is still being transferred to the water. Eventually, the water reaches boiling point, thermal energy from the hot plate is still being transferred to the water. The effect of this thermal energy on the water is molecules escape from the liquid as a vapor and bonds broken, attractive forces overcome. Molecules gain potential energy or work done to separate molecules to overcome the forces. The bulb of the thermometer is placed into a beaker of warm water. As the liquid expands, it moves along the tube. In terms of molecules, why a liquid expands when heated is because molecules gain kinetic energy, move further apart. In terms of molecules, why liquid expands more than a solid when heated because forces between liquid molecules weaker than in solids and less energy done to separate the molecules, greater separation for the same work done. How the sensitivity of the second thermometer compares to sensitivity of another thermometer. A second thermometer has a larger bulb that contains more of the same liquid than the thermometer shown. Larger bulb that contains more of the same liquid. Greater sensitivity because volume increase of liquid in second thermometer is greater. Liquid move a greater distance for the same temperature increase. Greater sensitivity, volume increase of liquids in second thermometer is greater, and liquid move a greater distance for the same temperature increase. How the range of the second thermometer compares with the range of the thermometer's smaller temperature increase for liquid to reach the end of tube, and it expands more, have greater sensitivity and tube of their same length. One evident problem that is a result of thermal expansion is visual bucket in hot weather. One way of solving this problem is allow gaps at the end of the bridge. As the bridge expands, the gap closes. Movement of the pollen particles around them have result zigzag irregular. Random zigzag have result irregular. Random and zigzag. Movement in terms of molecules of the liquids and the pollen particles is that water molecules move fast. Pollen particles are very massive and they collide. And uneven collisions from different directions cause random movement of liquid water molecules to move randomly. Medical professionals sometimes rub ethanol over the skin of patients. Ethanol evaporates readily at room temperature, hence the high specific latent heat of vaporization. Whether the patients experience heating, cooling, or neither is decided whether ethanol is applied cooling, because thermal energy used to evaporate the ethanol overcome the attractive forces between molecules. Thermal energy taken from the skin and more energetic liquid molecules escape, and less energetic molecules remain, so there's a lower temperature of the skin. Effect on the rates of evaporations of ethanol when a fan blows air over the patient's skin is greater. How using the holder makes it more comfortable to hold the cup is because air is a good insulator and holder reduces conduction, less thermal energy conducted to hands. Temperature of outside of the holder is lower than the cup, or less energy to the skin to the hand. Temperature of outside of the holder is lower than the cup. A student carries out experiments on the cooling of the hot drink, described A, with and without the holder in place. He finds that holder only reduces the rate of cooling slightly. So you insulate it, you put a lid, you put the water bath. Another action is that reduce the rates of cooling effectively. Another actions that reduce the rates of cooling more effectively is the way that pour the lid on the cup, less no convection from surface, less evaporation from surface. Method of thermal energy transfer from a star to vacuum or space is radiation. Specific latent heat of fusion is the energy required to raise the temperature. The specific latent heat of fusion is the energy required to change the state of the solid, 1 kg of the solid. Energy transfer when 1 kg of a substance freezes or melts, changes state. A cup of water contains 250 cm of water at a temperature of 0 degree. An identical cup contains 250 cm of a mixture of ice and water at a temperature of 0 degree. State and explain which cup contains the liquid with the lower temperature after 10 minutes. A cup containing mixture of ice and water, because mixture of ice and water will remain at 0 degree until all ice is melted, but temperature of water at 0 degree rises, energy needed for change of state, so temperature doesn't rise until this taken place. In terms of molecules, how the evaporation of sweat cools the person. So thermal energy is needed to evaporate the salt, and thermal energy is required to, there's work done for the evaporations of the salt to form the salt. Thermal energy is used, and it left the particles with less kinetic energy. So it decreases the temperature, increases skin. The intermolecular bonds are being broken, and there is it evaporates through the surface. It evaporates from the surface. Particles with more kinetic energy are going to leave as gas. During evaporation, more energetic molecules with higher kinetic energy escape from the surface, lower energy remain. Thermal energy is taken from the person, so the person cools down. This process is more effective when the wind is blowing because there will be a higher concentrations gradients between the water molecules and the surroundings, so there will be more particles with energy that have greater kinetic energy to evaporate because they have enough kinetic energy to break as gas. Greater evaporation of salt as wind blows the fast moving and molecules away. Molecules do not re-enter the liquid. As for in terms of molecules, how evaporation cools the water in the curve. Faster energetic molecules escape into the air. Average kinetic energy of molecules decrease. Temperature is related to speed. Less energetic molecules remains in the water. How electrons transfer thermal energy through the metal can? By conductions, by lattice vibrations, and electrons move through the metal can freely, localized electrons, and then electrons will travel through the matter, and electrons will hit the other distant atoms, and the distant atoms will gain energy and lattice vibrations, and electrons are going to transfer their energy to other electrons when hitting. So the electrons gain energy by hitting the nearby particles. Atoms vibrate. Vibrating atoms hit the electrons. Electrons travel through the matter. Electrons hit distant atoms. Free atoms localize electrons. How temperature of a sulfur in the beaker is deduced by measuring electromotive force and use calibration. Boiling point is temperature at which liquid becomes a gas. The metal tap is off, and there is a fuse in the cable that connects the heater to the mains. This is to prevent electrocutions if the live wire touches the metal case. So the currents in all four is large and fuse will melt. Fuse will stop the current. Break circuits. Energy from the sun reaches from the earth and warms the road by radiations, where black surface is a good absorber and white surface is a good reflector. And it throws electromagnetic radiations like infra, ultraviolet, and also visible through radiations. Radiations, infra radiations travel through space, absorbed by the rod. Travel through space and absorbed by the rod. One reason why temperature of the rod is greater than of the sea because it has a smaller specific capacity, so the same rate of energy are transferred to both, but since it has a smaller heat capacity, so it will have a higher energy and the temperature will increase. Rods are good absorbers of radiation. Black surfaces are good absorbers of radiation. C is a poor absorber of radiation. Air above the rod is heated by the warm rod. The air above the rod is heated by the warm rod. Describe how this affects the molecules of the air. The density of the air rises. The air rises because the density decreases. And is replaced by the cool air. The molecules of the air gain kinetic energy and move further apart. Explain how convections produce this breeze. So, hot air rises because the density decreases and cold air sinks because the density increases. Hot air is going to be replaced by the cool air from the sea dirt, and the land and the hot air is going to rise. Density of air above road decreases. Air rises, air above road is replaced by the cool air. The form of energy stored by the battery is chemical potential energy. The environmental benefits of the electrically powered bicycle. Environmental benefits of this electrically powered bicycle is it has less noise, it has no gaseous pollution, it does not contribute to greenhouse effect, it uses no fossil fuel. State and explain two features of a liquid ingress thermometer that are necessary for linearity is a constant cross-sectional area and the liquid that expand the same at a constant rate for each temperature rise. So there is a ball of constant cross-sectional area. Same increase in volume of liquid. Same movement change in that of liquid. Liquid has a constant thermal expansion. Both constant cross-sectional area because same movement, change in length of the liquid. There is a bar for constant cross-sectional area because same movement change in length of liquid and for the same increase in the volume, and liquid has constant thermal expansion because liquid moves the same distance for each degree temperature rise. Liquid has constant thermal expansion because liquid moves the same distance for each degree temperature rise, and both constant cross-sectional area because the same movement change in length of liquid and for the same increase in volume expansion of liquid. Same movement and same increase in volume. Small particles are large, but air molecules are small. But air molecules have a very high speed, so they collide and they bombard with their small particles, and there is a change in direction because there is uneven collisions, and it will move random movement and it will change the directions. Air molecules bombard small particles. Air molecules are small, compact small particles. Air molecules are very fast moving. Air molecules move in random directions. Collisions exert unbalanced force on small particles. The temperature of the air in a sealed glass container is increased. Explained in terms of molecules, why the internal energy of the air increases because the kinetic energy and potential energy of molecules increase, hence internal energy increase. In terms of molecules, why the pressure of the air also increases because since the kinetic energy and potential energy of the air particles increase, so they will collide more often and there will be more force per unit area, and pressure is equal to force per unit area, and there will be more change in momentum since force is equal to the rate of change in momentum. Molecules hit more. Bigger change in momentum of molecules. Molecules hit more often. Molecules hit worse harder. Specific capacity is the energy required to raise 1 degree. Energy needed to raise the temperature of a substance by 1 degree, of 1 kg of a substance by 1 degree. Energy required to raise the temperature of a substance by 1 degree, and energy required to raise the substance by 1 degree, and also 1 kg of a substance by 1 degree. When the heater is first switched on, the temperature of the air immediately below the ceiling increases more quickly than the temperature of the air in the rest of the room because it takes time for the heaters to heat the surroundings, and also it takes time for the heater to raise temperature. Thermal energy is going to lose to the surroundings, and time for the thermal energy to reach other room by convection. Because one air rises and it will have a lower density, so cold air will sink to the bottom for the heater to heat up. Think what happens to the motions of helium particles as their temperature increases. As the rubber structures and the volume of the helium increase, the pressure of the helium remains constant. Explaining in terms of the particles of helium how the pressure of the helium remains constant is because higher temperature means particles collide with rubber harder and with more force with greater momentum change. Larger volume means particles collide with rubber less frequently. Larger volume means larger surface area for particle collisions. The effect of larger volume cancels the effect of increased temperature, so the increase of larger area cancels the effect of larger force, so P equals to F divided A. The efficiency of the lamp is less than the value determined in AIR because temperature change is an underestimate due to the thermal energy loss. Temperature change is an underestimate due to thermal energy loss, where thermal energy is transferred from the water to the air, and energy other than light will transfer in the lamp filament internal structure, and some water will evaporate. Temperature change is an underestimate due to thermal energy loss. Thermal energy is transferred from the water to the air. Energy other than the light transfer in the lamp filament grasps the internal structure. Some water evaporates. Point X is the point the orbit closer to the sun, and point Y is the point further away. The orbital speed of Pluto varies as it orbits the sun. The orbital speed of Pluto varies as it orbits the sun. Describe how the speed of Pluto varies as it moves from X to Y and then back to X. Speed decreases from X to Y and then increase from Y to X. In terms of energy transfer, why the speed of Pluto varies in this way? Because gravitational potential energy transfer to the kinetic energy, and kinetic energy transfer to gravitational potential energy from X to Y. Speed decreases, kinetic energy decreases. Most gravitational potential energy at Y, or least gravitational potential energy at X. Total of gravitational potential energy and kinetic energy is constant. Pluto is a white surface. It alternately faces towards and away from the sun. How this affects the temperature of Pluto? As it rotates on its own axis, white surface is a poor absorber, good refractor. Black surface is a good absorber. So the white surface increases in temperature less when facing the sun, and the white surface decreases in temperature less when facing away from the sun. The black surface increases in temperature more when facing the sun. The black surface decreases in temperature more when facing away from the sun, and last variations in temperature on white surface during one whole rotation. So there will be less variations in temperature on the white surface during the one whole rotation. There is a less variance in temperature on white surface during one whole rotation. Less variance in temperature on white surface during one whole rotation. In terms of particles, how pressure of gas is changed. Pressure decreases because less frequent collisions and less kinetic energy, less force. Pressure is force per unit area. So, lower rate frequency of collisions. Particles collide with smaller force. The term absolute zero is temperature at which particles have the least kinetic energy, the lowest possible temperature. Reason why the time calculator in that is the minimum time needed to increase the temperature of the air in the room is because thermal energy is transferred to furniture, walls, objects in the room. Thermal energy is transferred through windows, doors, floor, ceiling. Main methods of thermal energy transfer from the room to outside, which are reduced by this type of window, is conduction and convection. The state of matter, solid, liquid, gas is the greatest thermal expansion and release. So, gas, solid. Solid particles vibrate, gaseous particles move freely, solid particles in fixed positions, gaseous particles randomly arranged in container, gas particles move quickly. An energy required to raise 1 kg by 1 degree. Name of wave process that occurs as the wave passes through point A is diffraction. Name of process that occurs as the wave passes into shallow water, refraction. The wavelength decrease, frequency stays the same, speed decrease. Echo, diminish, magnify, via same size, same way as object. Image formed by mirror is virtual because it cannot be projected on screen, like there's a pass-through image. Monochromatic is light of a single frequency. Compressions and reflection is regions where particles are closer together than normal, region where there is greater pressure than normal, region where particles are further apart than normal, when there is lower pressure than normal. Light does not need a medium to travel through, sound needs a medium to travel through. One side of wavefront enters the solid first. Wavefront does not all hit the solid at once. And this side slows down first, so this side delay first relative to other side. And angle of wavefront changes, so different parts of wavefront delay by different amounts. Refraction. Wave move faster in region B. Refractions and wave move faster in region B than in region A. Sound travels faster in solid than in air. Person waiting at a station hears the sound of the train through the rails before he hears the sound through the air. Object closer to lens than one focal. Image same side of lens as object. Image same side of lens as object. Image further from lens than object. Image enlarged upright goes up, Richard. Diffraction. Why were incident parallel rays meet after passing through the lens? Why on principal axis? Why were incident parallel rays meet after passing through the lens? The vibrations of particles of transmitting medium. The directions of vibrations of particles of transmitting medium is perpendicular to the direction of travel of wave. And one is a medium, another one only. Carbon test. An aqueous name for refractor cell. The wave that form an aqueous type of longitudinal wave. Longitudinal wave are made up of compressions and reflections.